to use the division that we did in the last lesson now to solve polynomials. So the learning target is that you can find any remaining factors of a polynomial given one of the factors, and using either synthetic division or, if you like the other way, long division. On your note sheet, the first one is kind of a geometry type problem. It says the volume of a rectangular prism is given by this equation shown over here. Find the missing measures. Well, if you remember back from geometry, volume of a rectangular prism is length times width times height. So they tell us that one of these measures is x minus 4. So if we have our length and width and height here, if one of them is x minus 4, let's just say it's the height here, what are these other two going to be? Well, we would find it by dividing. So what we want to do is take this and divide by that one. And that takes us back to that synthetic division we did yesterday. So we want to set this equal to 0, solve it. And that tells us one of the measures, or our multiplier is going to be 4. And then we want to put these other coefficients from our volume over here and write them out. So the first one's a 1, the second one's a 3, next one's a negative 36, and the last one's 32. So now if we go through and do synthetic division, or if you like the line division way, you could do that too. Find out what's left over. So drop the first number down 1. We multiply with 4 and we get 4. Add these up, we get 7. Multiply again, we get 28. Add them up and we get negative 8. Multiply with 4 again and we get negative 32. And the last one's 0. Reminder that this last one then is your remainder. Okay, so the numbers left over here, those ones, if we put them back with the variables, would be x squared plus 7x minus 8. Okay, but the problem said, what are the other two lengths? So within this statement we got left right here, there are two more things. We want to find what's the width and the height still. So that means we need to break this down farther. To break it down farther, now we use that factoring stuff you did from previous units. So what are the two things that are going to multiply to negative 8 and add to 7? Looks like here we'd want to do a plus and minus 1. So those would be the other two things here. The length and height would be like x plus 8, and the other one would be x minus 1. If we multiplied all three of these together now, that would give us that volume. So those would be the missing measures right here. So we're going to be doing stuff like that today, finding all the different factors. Okay, so the directions say, given one of the factors, use division to find the remaining ones, and then they want us to write it out in factored form. So we're going to do the same kind of thing we just did on the last problem. If we put this equal to 0 over here and solve, negative 3 is going to be our multiplier for our synthetic division here. So we got negative 3. Okay, our coefficients are 2, 15, 22, and negative 15. So now we're going to see what's going to be left here. Drop the 2 down, multiply, add, multiply, add, multiply. 2 negatives is going to be positive 15, remainder 0. So what we got left here now is 2x squared plus 9x minus 5. Again, though, we're not done. We want to break this down farther. What are the things remaining within that? So this is factoring again. A little bit different from the last one, though, because now we got a 2 here. Remember, when there's a coefficient in front of the x squared, that means one of these is going to have to be a 2x, and the other one's going to have to be a single x. Now we look over here. We know that the two numbers need to multiply to be negative 5. So now you got to kind of guess and check. What would those be if we put them in here? Negative 5 could be like 1 and negative 5. Let's try that out. What if we put 1 and negative 5 in here? That might be right, but we want to check it. What do these multiply to? What do these multiply to? that would be negative 10x, and this would be 1x. If we add that up, that's negative 9x. Does that match what we have here? Look close. It's the same number, but wrong sign. So that must mean if we just switch these signs around, then I believe it's going to work for us. So let's change this here. Let's change the two signs around. Let's make this one minus and this one plus. Now if we were to multiply those, you'd get negative 1x and 10x. That does add to 9. Okay, now the last part of this problem, though, they said write this out in factored form. That means what was originally being multiplied that would give us what we had there? Well, it would be the two answers we got on the bottom here, 2x minus 1 and x plus 5. Okay, and the third one would be what we originally divided by, x plus 3. That would be the solution to the problem. That's the factored form of this right here. Okay, so that's what you're kind of doing on these different problems. Why don't you pause the video and see if you can try number 2 here and see if you can find that one in factored form. Okay, let's check what you got. If you got it in, if you did the synthetic division, you should have ended up with what's here. Remainder is 0 here, so we are left with x squared plus 3x minus 10. What does that one factor down further to? What's going to multiply to negative 10 and add to 3? Looks like we'd want positive 5 and negative 2. So then the complete factored form of this one would be those two we just had, and the one we are dividing by, x minus 7. If we multiply all three of these together, that would give us what was there. So our answer would be right here. All right, not too hard. It's just combining some of the stuff we just learned with some of the stuff we had done previously. All right, number 3. They want us to do the same thing on this one. Okay, recall though from the last lesson, when we see a number here in front of the x, that means we got to start by doing some division here. So we want to divide all these by 2 here to start. Okay, so that would mean these cancel out. We got x plus a half equal to 0. Looks like our multiplier here is going to be negative half. And then we want to divide all these by 2. So we got 3. 2 doesn't go in there, so we'll leave that as a fraction. 2 doesn't go in that one either. And we got negative 5. So do the synthetic division. We got 3. 3 times negative half is going to be negative 3 halves. We want to add these up. 29 minus 3 is 26. So we get 26 halves. 26 divided by 2 would be 13. Multiply again. That's going to be negative 13 halves. Add these up. Negative 7 and negative 13 would be negative 20 over 2. Negative 20 over 2 is going to be the same as negative 10. Multiply again. That would be positive 5. Remainder 0. So we get 3x squared plus 13x minus 10. Now we want to factor this more. So we're going to have two terms here. One of them is going to be a 3x. One's going to be a regular x. We know it's got to multiply to negative 10. So this is where you got to kind of check and see, okay, what's going to multiply to negative 10? Either 10 and 1 or 5 and 2. Let's try 5 and 2 here. And if it's negative, we know one's positive, one negative. So let's see if 5 and negative 2 work. Okay, if we multiply those, that's 5x. That's negative 6. If we add that up, that's negative 1. That's not matching the 13 we got there. If that happens, that means if it's not the same number, you got to switch this up. These numbers are not in the right spot. So let's trade them around and let's see if minus 2 and plus 5 work. Now if we multiply them, that's 15x. That's negative 2x. Those do add up to the 13. That's the factored form. So now our last step, we want to write this out in factored form. So the three things that have been multiplied would be 3x minus 2 x plus 5, and what we divided by originally, 2x plus 1. If all those get multiplied together, you get what we started with. All right. Why don't you again pause the video, see if you can try number 4 here, and see what you get. Okay, let's check. If you set it up, it should look like this. Now you want to do the division. If we multiply 5/3 times 2, that's going to be 10 thirds. 2 times 5 is 10. Add these up, it'd be negative 27 thirds. And we know if we divide negative 27 by 3, that's going to be negative 9. Now multiply again. Negative 9 times 5 is negative, negative 45 over 3. Negative 45, though, over 3 is going to be the same as negative 15. My mistake. And then if we add that up, that's negative 5. Multiply again, you're going to get negative 25 thirds, and adding that up, you get remainder 0. So now you want to factor this out. What's that one going to factor out to? It's going to be 2x and x. So we got to multiply to negative 5. If you play around with it, I think the combination that's going to work is having negative 5 there and positive 1 there, because that's 1x, that's negative 10x, and those add up to negative 9. So for your answer, you want those two along with that original one of 3x minus 5. That is the solution that you should have. Okay, on the back, here's another geometry one similar to that first one we started with. So they said the volume of this rectangular prism is shown. The width is x plus 1. What would the height and length have to be? Okay, so we know from before, volume is length times width times height. So if we want the other two, we need to do some division here. So our factor here, if we set it equals 0, would be x equals negative 1. So that's our multiplier. Put our coefficients there. And let's divide it out. So 1, multiply, add, multiply, add, multiply, add. Our remainder is 0, so we're left with x squared plus 2x minus 3. So now what does this factor into? Looks like the two numbers that would multiply to negative 3 and add to 2 would be positive 3 and negative 1. So that would be the length and width. Length and width would be both of those. All right, and it looks like it's in inches. Okay, the last one, number 6, they want us to do a similar thing, but now we got a triangle. Now, triangles are a little bit different than the volume we were working with. Triangles and area, from geometry, you know, if you have some type of triangle, the base is important. You're also going to need the height of that, and the area. It's not just base times height with the triangle, it's base times height divided by 2, or half base times height. So if we know what the area is, in this problem they tell us what it is, and the height they tell us, they want to know how long should that base be. Well, what we need to do with this little equation then is solve it for b. What would the base equation be? Well, to do that, we'd want to times both sides here by 2. Let's get rid of that 2. Now we got 2 times the area equals base times height. To get rid of the height, we'd want to divide by the height. And then we know what the base is. The base is, in this problem, going to be whatever 2 times the area is divided by the height. Okay, so let's see what that is if we put all the stuff in. Our base is going to equal 2 times our area. This is the area they give us. 16x to the 4th minus this. Big, long area equation here divided by, so we want to divide all this by the height, which is x minus 4. Well, now this just looks like one of those synthetic division problems. The thing we're going to need to do, though, first, we got this 2 out here. That 2 needs to get distributed throughout here. So really looks like what we're going to be dividing is 32. That's going to be 120. It's going to be 56. It's going to be 112. And 64 divided by x minus 4. Okay, so now if we go through and do synthetic division, we should get it. Why don't you see if you can finish this problem now and see what you get? All right, if you did division, you should end up with what's here. Looks like we get remainder 0 again. So if you write out the rest of the answer, you're going to have 16. The next one should be with 1x. The one up from that then should be x squared, and then looks like the biggest one should be x cubed. And so that right there would be how big the base of the sail would be. All right, so that's how you use synthetic division or long division to factoring to find out what all the factors are of something. Try some out now on the practice.